Today we're looking at what is called the change of base law. So on your formula sheet, it tells you that log base a of x is equal to log base b of x over log base b of a. So what we're doing is we're taking any log with any base and we're changing it to a base of our choosing. And I want to know, why can I do this? Like, how did we come up with this log base b of x over log base b of a? So if we start off with the left-hand side, so log base a of x, and I'm going to call that y, I have to call it something so that I can operate with it. So using our definition of a log, if log base a of x is equal to y, then we know that a to the power of y is equal to x. Okay, so that's just your definition. So we're working with that. A to the power of y is equal to x. And then what I want to do is I want to take the log of each side of this equation here. Okay, except I'm going to choose my own base, and funnily enough, I'm going to choose log base b. So take log base b of the left-hand side, and just using what we know about equations, whatever we do to the left, we have to do to the right. So that means it's equal to log base b of x. Okay, but using one of the laws that we looked at last lesson, we know that if we've got this index y, that by definition, that means the left-hand side is equal to y log base b of a. Okay, so we just worked with that left-hand side. Well, that means I can say that y is equal to log base b of x all over log base b of a, because all I've done is divide through by log base b of a. Okay, looking very similar to what we've got up in that box up top. But going back to our definition, so back up here, y is equal to log base a of x. So that means that log base a of x is equal to log base b of x all over log base b of a. So the point of this, well, the point of this is our calculator knows what logs with base 10 and logs with base e are. So I can take any other log, like what we were looking at last lesson where we had bases of 2s and 3s and 5s and 7s and anything else, and I can change them so that they're a log base 10 or a log base e, and it's completely up to you which way you do it. Okay, so having a look at this first example, we've got log base 2 of 9. Now, I don't know what power I need to raise 2 to get the answer of 9, but what I do know is that log base 2 of 9 is the same as log base. Now you can choose here. I'm going to use base 10 of 9 all over log base 10 of 2. The only rule is they both have to be the same base. That's what it tells you up in where they've both got log b. Okay, and then this is something that I can just type into my calculator. And when I type that into my calculator, my lovely calculator says, hey, that power would need to be 3.169925001. Now you can use your log button, the log, because that's base 10, but you could also use your ln, so base e. All right, so we've got log base 4 of 3, then I know that this is equal to the natural log of 3 all over the natural log of 4, which is 0.7924812,504. Okay, well, it becomes really useful to solve things like this. 2 to what power is equal to 7? So there is no number, and previously we used guess and check, and we got some sort of approximation, or we said what was the least number of years that this would have to be invested for, or something like that. Now we can get exact answers. Okay, so we say, well, if 2 to the power of x is equal to 7, then using my log law, my log definition, then I know that log base 2 of 7 is equal to x. That's just your definition of a log, right? Well, I can now change that to say log base 10 of 7 all over log base 10 of 2. And again, you could use base E and use the ln button. They're still going to give you the same answer. And that comes out to be 2.807354922. So this is much easier than guess and check. Okay, it's a fairly straightforward idea though. So we're going to leave it there. Good luck, and I will see you in class.